All right. Good morning, good afternoon, good evening, everybody. In this video, we're going to talk about how to write chemical formulas based off of names. So we're going to be using the same chart, right, except we're using this one here, how to write formulas. And we're going to be utilizing our ion chart again as well. All right, so let's get started. So the first one we're going to look at is a chromium 2 chloride. Okay, so now let's explore our other sheet here. So first question. So the other one asks, does it start with H? Right. And the purpose of this is determining if something is an acid or not. We're not doing acid naming to save some time, but you can use this for those things if you'd like to. Right? So that's the point of these two first questions: is it an acid? And just like the other one, we always start here in the upper left-hand corner. So it does not contain the name acid. So then we come down here. Does it have the name dichromate? Let's see. Chromium chloride. Okay, so I have chrome, but it's not dichromate. So no. Okay. So no. Does the last name have a prefix? It does not. It's just chloride. There's no mono or di or anything like that. So nope. So we're here. So it says first write the cation and anion second. So write cation first and anion second. Write the charges of each ion. Crisscross the charges for the formula. Reduce if necessary. So I'm going to come down here and I'm going to look at this right here, because this tells me how to crisscross. Okay, so it's chromium 2 chloride. Okay, so and remember, it's always cation written first and anion written second. That's the way we did naming in the other video. So this is my cation right here, which is positive. So I'm going to look at my ion chart and I'm going to look in the metals. And if I come in, chrome is right here. Here's chromium. I need to get better at drawing boxes around things. But anyways, here's chromium, okay, and chromium 2, which is a Cr2+. And then we know chloride, which is right here, from the other ones, which is Cl-. So Cr2+, Cl-. Oops, sorry. Probably going to get some motion sickness here. All right, so I write the anion first, a positive one. So that's Cr2+, and then Cl-. So how to crisscross the formula, it shows us here. You take the charge of 1, right? And we're just interested in the number, not the actual symbol, just the number. So 3, and it becomes the subscript of the other element. And then here, remember, we don't write ones, but that's kind of what's there, and it becomes a subscript of this one over here. So if I crisscross, this 2 will come over and become the subscript of chlorine, and chlorine has a 1, and so that becomes a subscript of Cr. And so we end up with CrCl2. Right? So this is a quick way of figuring out, but let's talk about why. Why is it Crl2 to Cr? Right? And it has to do with the charges. So if I have 2 plus charges here, and I have 1 minus charge here, this needs to be neutral. Because that's the way nature works. All right, when it forms these compounds, these ionic compounds, it's neutral. Right? So in order for this to be neutral, I have to have, all right, so my Cl is only 1 minus. I need another minus. And so I double up on the chlorine. Right? So Cr is just these two here. Right? But I need 2 Cls, right, to get the 2 minuses to even it out. And then that's where we get the CrCl2. Okay, so our charges have to be balanced. Okay, so good job. We have chromium 2, CrCl2. Very good. All right, so let's do some more examples. I'm going to clear this out. It's probably annoying. Listen to me erase, but if I use clear palette, it'll take away my pictures too. I don't want that. So okay, so what are we working on next? We're going to do another ion one. So let's see here. Aluminum or aluminium for our friends across the pond there. Phosphite. Aluminum phosphite. So if I come here, okay, does it start with acid? No. Does it have dichromate? No. Does it have a number prefix? No. Right? It's just phosphite. There's no di or tri or anything in front of it. So we're doing the exact same thing. Cation first, then anion, then crisscross. So I have aluminum phosphate. So come here, find aluminum, which is right here. And that's a 3 plus. You can see, get in here. Okay, so that's a 3 plus. And then it's phosphite, ITE, right? So, this ITE tells me it's probably polyatomic because everything over here ends in IDE. Okay, and so I'm going to look in my box here, my polyatomic ion box here. I'm going to turn this up a little so that we can get to it. Remember that your metals are over here. Okay, left of the stair step are metals. Okay, so I'm looking for phosphite. This is in alphabetical order, so I just need to find P's, right? And then perchlorate, pyridate, right? Phosphate. Ooh. There is no phosphite on here. I don't like that. Okay, well, let's see if it's over here, because there's common ions over here. Nope, it's phosphate. Okay. Okay, so there's no phosphate, right? There's not one over here. There's not one over here. What are we going to do with ourselves? Little trick that I'm going to show you. So we have phosphate. Phosphate, so ATE, is PO4 3 minus charge. Okay. Something that we see here, let's get closer to it actually. Okay. So here's phosphate, PO4 3 negative. Okay. If we see here, if something ends in ITE, it has one less oxygen. Same charge. But one less oxygen. And so this is actually PO3 3 minus. And so now we can use those two things. So aluminum is Al3 plus. Phosphite is PO3 3 minus. So now we do our crisscross. So I would end up with Al3 PO3 3. Now, if you remember from here, it says reduce if necessary. What that means is if we can reduce our subscripts, we need to reduce our subscripts. And so I can actually divide this by 3, and end up with Al PO3. And it's the same, right? It's the same ratio, 1 to 1. And so this is my final formula, AlPO3. That's what it means by reduce if necessary. If you remember from writing ionic formulas, if you have more than one polyatomic ion, you have to write it in parentheses and then put the number of polyatomic ions on the outside, like that. Okay, so I'm going to clear this up and be right back. Okay, let's do some more examples. This time we're going to do one that's not ionic. So let's do sulfur hexafluoride. Sorry, I'm reading and writing at the same time. So sulfur hexafluoride. So if we start here again, I'm not going to zoom in because we've seen it. Hopefully you have yours going along. Does it start with acid? No. Does it start with dichromate or end with dichromate? No. Does the last name have a prefix? Yes. And that's something important to recognize. Are these prefixes? So hex. So yes, right here is where we're going to be. Now I'm going to zoom in because we need to read this part here. So write the symbol for each element. Write the number indicated by the prefix at the bottom right of its symbol. So we come here. Okay. First one up is sulfur. So I find sulfur, which sulfide, same thing. All right, so and the chemical symbol is S. So S. Next, fluor tells me that it's fluoride here, or fluorine. So chemical symbol F. And hex, if I look at my prefix chart here, hexa is right here. That equals 6. Oop, moving the wrong thing. And so SF6. That's my chemical formula. Okay, so with this, all right, it's not ionic. They don't have charges, and so you don't have to do the crisscross. All right, let's try another one. Okay, so our next one is diantimony trioxide. So if we go through our steps here, does it start with acid? No. Does it end in dichromate? No. Does the last term have a prefix? Yes. And so we're back down here, which was write the symbol for each one, use the prefixes to determine the number, right? The subscript. Well, I actually have two. I have di on the front of my first number, and I have tri on the front of my second number. Or not number, I apologize, element. So let's look up our chemical symbol. So antimony, we're going to find, let's see here. Sorry. So antimony. Okay, so we're looking at antimony, and antimony is right here. It's a tricky one. Its chemical symbol is SB. Okay, but that's where it is. So we have the symbol SB. We don't need to worry about the charges, right? I'm using the ion chart because I can use it for both things. You might need a periodic and an ion chart. But anyways, so SB is the symbol. And like I said, it's a tricky one because that symbol is nowhere close to the name that we use for it, right? So sometimes instead of going through and looking through for a symbol, like, you might look at this one. Can't see my white ink. You might look at this one and think, oh yeah, that's antimony. It's AT. Right? I'd go through and look for names. Okay? So we have antimony, SB. This is oxide, so I know that symbol is O. Okay, so I wrote my two symbols, and then I look to my prefixes to see if I have any subscripts. This one has 2. This one has 3. So SB2O3. That is your chemical formula for this name. Let's do another quick one because this is starting to run long, and I'm not even going to clear out. I'm just going to write it down here. All right, so again, you write the symbols because we can go through the whole thing, but it doesn't start with a metal. It doesn't have dichromate. It does have a number prefix. Does not contain the word acid. So we're in the same boat as we were here. Okay. I know that oxide is O. Carbon, it's fairly common. Hopefully you know it's C. There's no prefix on carbon, so I don't have a subscript. And mono is the prefix in oxygen, so my subscript would be 1, except, like I said, in chemistry, we don't like writing ones. And so it's just CO. So one thing to keep in mind as we're writing out these names is you notice that you don't see monocarbon, right? Or the other one we did, monosulfur, right? We do not use mono on the first term. Okay, we do on the second one. We do not use mono on the first term. We just use the element name. Like I said, there's a lot of rules to naming things. But just remember, do not use mono in the first term. And if we look up here, oh, it doesn't say that, and I didn't cover that in the other video. I'll make sure I say it in class. All right. Because for this one here, prefix number, do not use mono on first element. Okay. So even though it says prefix number here, do not use mono. And they kind of cover that because it says, is there more than one atom on the first element? No, they tell you not to put a prefix here. So yeah, I kind of see it, but just keep that in mind. All right, well, that's our video. Hopefully it was helpful. Some things to remember. Your crisscross when you're dealing with ionic compounds will help you get the charge. Okay. The reason that this is important is on ionic compounds, right? So things made of elements with charges, charge has to be balanced. I'm pretty sure I spelled balance wrong there. All right. The charge has to be balanced, all right, or it's neutral. Okay, and then we don't use mono on first element. Okay, you do use the rest of them. You do use di, tri, tetra, all those, just not mono. Okay, hopefully that was helpful. Again, this was just kind of a review for you, and we're going to be going over this in class.